Hey, Algebra 1A kids, how we doing? Hope you had no problems with the notes that I posted. I know I said I'd post them on Mondays, and I promise I'll try that in future. I actually didn't end up posting them until Tuesday morning. Sorry about that. Had some issues with uploading. But anyways, we already did all these notes for 5.1, and so now we are going to do the evens, and that's going to be your practice. Now remember, this is new, so this is going to take you a little bit. It's going to take some extra work at home. You may even need to Google some of this stuff, get extra practice. Feel free to email me with any questions, ask your friends. Rewatch the video on graphing like 1,000 times. That should probably help. Graphs. Sorry. Okay, so anyways. All right, let's see how we did. I told you for this one, you are going to need to take this 4x minus 3y equals negative 3. Before you graph it, you had to change it into slope-intercept form. Currently, it's in standard form. You need it in y equals form. You should have subtracted 4x, so negative 3y equals negative 4x minus 3. Don't forget, these two are not like terms, so I can't squish them together. Divide by negative 3, and you get y, because these cancel out. Positive 4/3 x plus 1. Negative times a negative is a positive. Negative 3 times negative 3 is a positive 1. And this is what we're trying to graph. You start at the y-intercept. Follow your slope, which in this case would be up 4 over 3. If you want up and to the right. Or you could go down 4 and left 3 on the same line. Yes, I still have my awesome popsicle sticks. Just goes to show if you eat popsicles, you'd probably be better at math, and I am done. So that was just the simple graphing portion. Now let's get into the fun stuff. So number 4, this is actually a system of equations. We talked about in the other video, that means graph them, see where they touch. Top one shouldn't be too bad. We'll start at the y-intercept, which looks like that is positive 1. Okay. Then we're going to follow the slope here, which is negative 3 over 4. I almost always put the negative on top. But you could put the negative on bottom. What you cannot do is you cannot put the negative on both the top and the bottom. No, bad, wrong. So if you did it this way, this would say down 3 to the right 4. If you did it with the negative on bottom, it would say go up 3 and left 4. Notice both of those dots are in the same exact line here. Okay. A little trick here is x equals negative 4. Now, some of you are going to know right off the bat that that is just a vertical line like this. Some of you don't. What we did in class is we made a t-chart of x's and y's. And usually I'd say pick some random x's, but I can't because I know x is always a negative 4. So I'm going to pick some random y's. 1, 2, 3. Sure, why not? Or, I don't know, 1.8. And, yeah, well, whatever. We'll go with it. So now these are coordinates that I can graph. Negative 4, comma 1.8. That's right. Negative 4, comma 2. Negative 4, comma 3. You can see all of those points are in this line. Don't forget, you actually have to write your answer. I have not written my answer yet. My answer is negative 4, comma 4 because that's where they touch. That's this point right here. All right, then you had to go down to number 6. You had to do a little bit of math here. For number 6, you should have taken these two and changed them into slope-intercept form. This top one would say y equals negative 3x minus 1. The bottom one would say y equals 2x plus 4 once you changed those into slope-intercept form. Then we graph. Let's graph the top one first. I start at negative 1. Then I follow my slope of negative 3 over 1. Down 3, right 1. Or I could go up 3, left 1. Up 3, left 1. I'm going to put as many points as I possibly can. Then use my pops here. Yeah, it sounds like I'm talking about my dad. That's weird. Never mind. My popsicle stick. Then I do this bottom one. This one starts at a positive 4. And then my slope is 2 over 1. So I go up 2, 1, poop. Can't go up 2, so instead of going up and to the right, I'm going to go backwards. Down left, down left, down left, down left, down 2 left 1, down 2 left 1, so on and so forth. Remember, don't just graph these lines because the graph is just the way to find the answer. Don't forget the answer is this place right here where they touch. Okay? Hope we're doing good so far. We flip over to the back. Okay, now if you've already done this problem, number 8 is a little weird. Full disclosure, okay? One of them is in slope-intercept form. So we can graph that. This top one, y equals negative 2x plus 3. Start at positive 3. Slope of negative 2 over 1. Negative 2 over 1. Negative 2 right 1. Negative 2 right 1. You could go backwards. Up 2 left 1. Graphs, 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 graphs. Sorry. Okay, connect them. There's my line. Fantastic. On the other hand, here, 2x plus y equals 3. That we have to change into slope-intercept form. Here's the nice part. It takes like one step. If I subtract 2x from both sides, I get negative 2x plus 3. You might realize it right away, you might not. If you don't realize what I'm talking about, you just start graphing this. Positive 3, slope of negative 2 over 1. Wait, what's going on? Then you see that this equation and this equation are identical. So if I were to graph these two things, they would actually lie right on top of each other. Let me use my popsicle sticks as a demonstration. I graph the first line. Then I take a second line and I graph it, and it lies right on top of the first line. So let me ask a weird question. Where do they touch? Everywhere. Same as y'all nasty people like making out in the hallways. But anyways, so what's my answer here? Am I going to list every single coordinate where they touch? No. I am going to say infinite amount of solutions. Now this is one of the most common ways to say it, infinite amount of solutions. I've heard people say infinitely many solutions or infinite solutions, whatever. Some people even just put like this sign. But if you are taking PSAT, which you got out of this year, but next year you will have to take the PSAT 10. But when you take that, I'm assuming if this is a multiple choice question, it'll say something like this, either this or infinitely many solutions. But all right, we got 2 more. Let's look at number 10. Number 10, you may have written nothing on the graphs and just put an NS off to the side, and you would be correct. The answer here is no solution. If you don't understand that, let's graph it. Let's do the top one first. I'm going to start at negative 3, put a dot, then I follow my slope. What the poop? I don't have a number. Yes, I do. There's a 1 here and a 1 here. So that tells me down 1, right 1, down 1, right 1. Or I could go up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1. Look at this gorgeous line. It's the best line I've ever seen in my life. Now I go to do the same thing here. I start at positive 4. Maybe you'll notice I still have a negative 1 over 1. Down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. Or up 1, left 1. And then I ask the weird, seemingly dumb question of where do they touch? And you should say nowhere. Because these two things are parallel. These two lines. Now the answer is not parallel. The answer is no solution, or just NS. Parallel just describes the situation. All right, let's finish this last one, and then we will call it good. 12, starting with -4. And then I have a slope of -1 over 2. Or you could think of it as +1 over -2, same thing. So you're either going down 1, right 2, or up 1, left 2, all on the same line. Should start bringing a popsicle stick to class next year. Now the last thing here, y equals 1/2 x minus 2, so I'm still starting at -2, and then I have a slope of 1 over 2. So up 1, right 2, up 1, right 2, up 1, right, oh, well it would be here. Or I could go down 1, left 2, down 1, left 2. And when I connect these dots, I'm done, right? Wrong. No, bad, wrong. Right here, that place where they touch is your answer, and you actually have to write down the coordinates. Again, when you take your PSAT or whatever, they're going to be looking for those coordinates. All right, there it is, people. That is how to solve a system of equations by graphing. Next week, we're going to be talking about the next way to solve a system of equations. This stuff is super common, so if you're struggling with it, that's okay. Just Google it, solving a system of equations by graphing. A bunch of stuff will come up, videos, explanations, whatever. Or shoot me an email, ask me questions, ask for more practice. All right, miss y'all.